Hello everyone, welcome back to my YouTube channel. Today we are going to learn Dijkstra algorithm, a very important shortest path algorithm in data structures and algorithm along with a Java implementation. Shortest path problem. The shortest path problem is about finding the minimum distance between vertices in a graph. This problem commonly appears in weighted graphs and real-world applications like mapping and networks. Next, why Dijkstra's algorithm? Among shortest path algorithms, Dijkstra's algorithm is the one of most popular because it is efficient and easy to implement when edges weight are non-negative. Applications. Dijkstra's algorithm is used to GPS navigation, network routing, game, AI pathfinding, and delivery optimization systems. Purpose of Dijkstra's algorithm. The main purpose of Dijkstra's algorithm is simple. It finds the shortest path from one source vertices to other vertices in weighted graph. The algorithm guarantees optimal results as long as all edges weight are non-negative. Then, key conditions. There are few important conditions for Dijkstra's algorithm. First, the graph must weighted, meaning every edge has a cost. Second, negative weight are not allowed. Third, it works with both directed and undirected graphs. If these conditions are satisfied, Dijkstra's algorithm works perfectly. Why Dijkstra's algorithm greedy? Dijkstra's algorithm is called a greedy algorithm. Why? Because at the each steps, it selected the nearest unvisited vertex. Once selected, its distance finalized, then it repeats the process. These local optimal choices together lead a optimal global optimal solution. Core concepts. To understand the algorithm, we need to know four core concepts. First, the distance array. Second, visited set. Third, edge relaxation. And finally, greedy selections. Important of terminology. Let's look at some important terms. Distance. Distance means the shortest known distance from the source to vertex V. Visited. Visited tells us whether the vertex has been full proceed. Relaxation. Relaxation is the process of checking and updating distances. These terms will help you to understand the algorithm clearly. Key formula. This is the most important formula in Dijkstra algorithm. If the distance to vertex U plus the weight from U to V is smaller than the current distance of V, then we update the distance of V. This is called relaxation and it helps to us find shorter path step by steps. Then algorithm overview. Now let's look at the overall idea of Dijkstra algorithm. The algorithm works in a loop. Select the closest unvisited vertex, update its neighbors, mark it as visited, This continues until all vertices are proceed. Then, first step, initialization. In the first step, we initialize everything. The source vertex distance is set to 0. All other vertices are set to infinity, meaning unreachable for now. All vertices are marked as unvisited. This prepares the graph for exploration. Then step 2. Select vertex. Next, we selected the unvisited vertex with the smallest distance. This is the greedy choice. By choosing the smallest distance, each time the algorithm ensures correctness. Step 3. Update neighbors. Now we examine all adjacent vertices. For each neighbor, we can calculate a new distance. We apply the relaxation formula. If the new distance is smaller, we update it. This is how the algorithm improves distance gradually. Next, fourth step, mark visited. Once all neighbors are proceed, we mark the current vertex as visited. This means its shortest distance is finalized. Then we repeat the process until all vertices are visited. Then example graph. Let's understand this with the example graph. We have 5 vertices A, B, C, D, E. Vertices A is the source. We will apply Dijkstra's algorithm step by step to find the shortest path. Example, initial distances. At the beginning, A has distance 0 and all other vertices have infinity. Only the source is known initially. Example, distance updates. We then process vertices one by one. Distance reduced as we find shortest path through immediate vertices. This is show how relaxation works in practice. Example, final distances. Finally, we get the shortest distance of A to all vertices. These distances are guaranteed to be optimal. This is the power of Dijkstra's algorithm. Why negative weights are not allowed? Dijkstra's algorithm does not support negative weights. Why? Because once a vertex is visited, the algorithm assumes its distance is final. Then, negative edges can reduce distances later. Then, breaking this assumption. For such cases, we use Bellman-Ford algorithm. Alternative approach, Bellman-Ford. Bellman-Ford handles negative weights and detects negative cycles. However, it is slower than Dijkstra's algorithm. So, there is always a trade-off between speed and flexibility. So, there is always a trade-off between speed and flexibility. Then, performance. The time complexity depends on implementation. Using arrays, it is O V squared. Using a priority queue, it becomes O V plus E log v, which is much faster for large graphs. So choosing the right data structure is very important. Then space complexity. Space complexity mainly depends on distance array, visited array, graph storage. Overall, it is efficient and manageable. Then Java implementation overview. In Java, we represent the graph using adjacency list or matrix. Initialize distance and visited arrays. Rapidly relax edges. In Java, we can implement Dijkstra's algorithm using either an adjacency matrix or an adjacency list. We use array to store distances and visited vertices and apply relaxation logic. Then Java code class definition. This slide shows the basic class definition and a constant value using to represent infinity. Then Java code. Dijkstra's method. Here we define the Dijkstra's method to initialize array for distance and visited vertices and determine the number of vertices. Then Java code main loop. This loop runs v minus 1 times. In each iteration, we select the vertices with the minimum distance and mark it as a visited. Then Java code relaxation. This part of the code performs relaxation by checking all adjacent vertices and updating distance if a short path is found. Java code min distance method. This helper method to find an unvisited vertex with a smaller distance value. Then output. Finally, this method prints the shortest distance from the source vertex to all other vertices. Summary. To summarize, Dijkstra's algorithm is a greedy, single source shortest path algorithm. It is efficient and widely used, but it does not support your negative edge weights. Thank you for watching. If this video helped you to understand Dijkstra's algorithm, please like, share and subscribe. See you in next video.